This video is about Dijkstra's algorithm, and Dijkstra's algorithm is used to find the shortest route between one point and another. So in this example, we've got roads through 8 villages, which are excitingly named A, B, C, D, E, F, G and H, and this is the length, 26, 48, 72 is the length in kilometres between these villages. What's the shortest route from A to H? Is it along here? Is it along here? Is it along here? Obviously there's a very large number of routes. Rather than try every single possible combination, Dijkstra's algorithm allows us to find this answer fairly quickly. Now in the exam you get a diagram that looks a bit like this. It's basically the same network with the same letters and the same numbers between them, but we can show our working for each town, each vertex, in these boxes. And there's a key here, vertex, so the top left hand corner tells you the letter A, B, C, D, etc., order of labelling, final label and working value, and this will become clear as we work through this example. So the first, well, we're going to start at A, so the first vertex we're going to label is vertex A, and so far we haven't travelled any distance, so that's 0. This is how it always starts. What we then need to do is to find a working value at every vertex that's directly connected to that vertex. So what's directly connected to A? Well, it's B and it's C. So the working value for B, the first working value is going to be 26, because 0 plus 26 is 26. And the working value for C is going to be 52. Now Dijkstra's algorithm says we should now look at the working values of all vertices without final labels. Select the smallest working value. So clearly the smallest number so far, these are the working values, the numbers in these boxes at the bottom. The smallest number is 26. So we're going to label B2 and its final label is going to be 26. Dijkstra's algorithm says we should now record a working value at every vertex that's directly connected to the vertex that's just received its final label. So what's just received its final label? Well, it's B. So we should now look at look at D and E and C, because these are the ones that are directly connected to B. So we've got 26 here, 26 plus 48, that's 74. So I'm going to put 74 in there. For E, it's 26 plus 72, that's going to be 98. So 98 goes in here. It's easy to forget that we should also do C. 26 plus 25 is 51. Dijkstra's algorithm says we should look at the working values at all vertices without final labels. Select the smallest working value. Well, the smallest number out of 74, 98 and 51 is 51. So C is the next one to be labelled. That's number 3 and that's 51. Dijkstra's algorithm says we should now record a working value at every vertex that's directly connected to the vertex that's just received its final label. What's just received its final label? C has. So what's connected there, there and there. We've done this one, we've done B, so we don't do that again. We've now got that. So it's 51 plus 38, that's 89. Important to put that comma in just to make sure it's not 9,889. So 51 plus 71 is 122. There's a 2 there. There we go. That's meant to be a 2. So now, which has got the smallest working value? Well, out of 74, 89, 122, 74 is smallest. So that's the next one. We've had 1, 2, 3, so now this is 4, and that's 74. Now we do all the vertices that are connected to D. 74 plus 49 is 123. Is there anything else directly connected to D? No, we've already done B, so it's just this one. So what's the smallest number out of 89, 123, 122? Well, it's obviously 89. So this is number 5. So the working value is 89. Now we look at the ones directly connected to E. 89 plus 24 is 113. And 89 plus 68 is 157. What's the smallest working value? Well, it's 113, so that's number 6. 113. What's directly connected to that? Well, that's H. 113 plus 43 is 156. Smallest working value of all those that have not been labelled is F, so that's number 7, so that's 122. Now we need to add 122 to 52, that's 174. Now because that is not smaller than 156, I'm going to put that in brackets. That didn't come out terribly well, so let's try it again. 174. I mean, try and fit the numbers inside the boxes. I'm working in slightly more difficult circumstances, so I've got to go outside the box here. I'll put this outside the box, but better if you can fit it in there. But the most important thing is to make your work legible. Anyway, so that's number 8, and that's 156. What we now need to do is to work out what the root is. Clearly the root is going to end at H, so I'm going to put that on the right hand side. Now the choices are from H. Did it come from G? Did it come from E? Did it come from F? And the way to work this out is to take 156, take away 52, and see if it equals 122. 156 minus 52 is 104, so that's not the shortest route. Is 156 minus 68 equal to 89? No, 156 minus 68 is 88. Is 156 minus 43 113? Yes, it is. So the node, or the vertex rather, before that should be G, so I'm going to write that there. So now we're at G. Is 113 minus 49 74? No, it's 64. Is 113 minus 24 89? Yes, it is. So that's the vertex before G. So now we're at E. Is 89 minus 72 26? No. Is 89 minus 38 51? Yes, it is. So the vertex before E is C. Now we're nearly there. Is 51 minus 52 naught? No. 51 minus 25 is 26 though, so the vertex before that is B. And then the last one, a bit obvious, is 26 minus 26 naught? Yes, it is. So it's A. So A, B, C, E, G, H is the shortest route, and the length, it's sometimes easy to forget to write this, but the question does ask you for the length, is 156. 156, I know, because it's there, 156. And just in case they're being really fussy on the mark scheme, don't forget the units. Now in part B it says there's a fair in village C and you cannot drive through the village. A shortest route from A to H which avoids C needs to be found. So you need to refer back to the other diagram. Working backwards, H is where we end up. It was G before that, it was E before that. But then referring back to the other diagram, you can see that we can't go through C, so we have to go through B and then through A. And then to work out the length, you just need to add up the lengths from A to B, from B to E, from E to G, and from G to H. And it works out to be 165 kilometres. Excuse me, we'll answer the phone. So